For the past few years, I have been hearing about the pollution in the ocean, but it is only at the end of October 2019 that I first learned about the ocean cleanup and their mission. I decided to make further research, and I have discovered that they're developing a technology to capture plastic in oceans, which I found very fascinating due to how simply and cleverly their system achieves the goal. First of all, I would like to scope the problem. There are 5 ocean gyres where the plastic accumulates, the largest accumulation of plastic being in the North Pacific Ocean, also known as the Great Pacific Garbage Patch. The remaining garbage patches, in descending order of amount of plastic, are found in the Indian, in the South Pacific, the South Atlantic, and the North Atlantic Oceans. The ocean cleanup are aiming to remove 90% of floating ocean plastic by 2040, but first their plan is to clear 50% of the Great Pacific Garbage Patch by 2025 using a cleanup system named System 2, planned to launch in 2021. The best description of the system was given by the founder and CEO of the ocean cleanup, Vladislav. Compare the function of the cleanup system to a rake in a large lawn full of leaves. To clear the lawn, one could pick up the leaves one by one, which would take forever, or one could use a rake to concentrate the leaves into one big pile, to then pick up the pile in one go. The initial designs of the technology were first showcased in 2014. Since then, the technology has taken a large simplification in its design. The team uses iterative design process approach. They test, learn and make modifications as frequently as possible to reach proof of technology faster. Comparing the latest design iteration, System 1B, tested in 2019, and its predecessor, System 1, tested in 2018, 1B was reduced in size by a factor of 3, and modular design approach was taken, meaning that the assembly and the commute processes were done much faster, and it allowed to make significant changes while offshore, as returning to land is a time-prohibitive process. The general idea behind the cleanup system is very simple. It autonomously navigates through the garbage patch driven by the wind, waves and current, whilst being slowed down by the parachute anchor to maintain a consistently lower speed than the plastic that is carried by the same wind, waves and current. The system catches and retains this plastic in its center until it's full and the vessel removes the collected plastic. During the tests, plastic was concentrated by System 1B by a factor of approximately up to 10,000. It is flexible enough to only absorb the small wind waves for its propulsion, whilst higher energy swell waves pass underneath the system. This limits the magnitude of the loads that the system absorbs. The design is made to withstand a significant wave height of 14 meters, which it is only expected to encounter once every 100 years. There are 3 remaining major parts that the system consists of. First, the 200 meter long floater, which had to be ensured that it does not suffer from any UV degradation due to exposure to sunlight. It was made from high-density polyethylene, as it has been used in fish farm floaters, which have been in service for decades without any degradation. Next, the cork line, which serves the purpose of keeping the surface plastic within the system. The cause of structural failures in System 1 was the stresses at the interfaces between the floater and the final major component, the screen. The solution to this was moving the screen under the cork line. The space created between the cork line and the floater was called the twilight zone. Plastic ends up in this zone because of overtopping over the cork line, and, although it is still technically within the system, there is no screen underneath the floater, so the plastic is not securely retained. The overtopping was decreased by introducing the increased buoyancy setup in the latest iteration of the design. The screen that was earlier mentioned was chosen to be 1.5 meters deep. This way the screen is not affected by underwater currents, which differentiate in velocity to the surface current. Also, a study shows that buoyant microplastics sizing between 0.5 and 5 mm are the most harmful to the marine environment. The concentration of these microplastics decreases exponentially with depth, approaching zero within 5 meters from the water surface, as the graphs show, noting that large pieces of plastic are more buoyant than the microplastics and therefore stay closer to the water surface. Every screen section is also fitted with 2 safety lines connected between the screen and the floater, in case there is any damage to the screen or the regular screen connection. The ocean cleanup's next milestone is delivering System 2, which will be designed to survive the ocean for at least 20 years. Once System 2 has been successfully tested, the project will be scaled up to a full fleet of these systems in the Great Pacific Garbage Patch. The operation is also planned to expand to the remaining 4 garbage patches. The audience I'm targeting with this communication is undergraduate engineering students. The video conveys the key engineering ideas of the ocean cleanup system in enough detail, so that the audience would find relevant concepts that they have studied and future career inspiration. Since my video does not only demonstrate a current global environmental problem, but also how a team of people are creating an engineering solution to it.